We've looked at hypothesis tests for the mean and the median. Now let's take a look at the hypothesis test for proportion. So we jump right into this with an example. So community college is investigating the proportion of students who complete their 2-year degrees and continue on to attend a 4-year school. Historically, the proportion has been 23%. Suppose a survey of 137 recent graduates showed 44 had gone on to a 4-year school. Does the data suggest the number of students going on to a 4-year school has increased? Okay, when you look at this, first of all, you notice there's no data. There's no sample average. There's no sample median. The parameter here is pi. It's a proportion. We talk about 23% historically have done whatever they've done. That's pi. We're talking about proportion. Now, just pulling off pieces here, this is suggesting that pi equals 0.23. And if I had 44 of 137, that means that p hat equals 44 over 137. So this is a sample proportion, and this is what they believe the true proportion actually is. So let's state the null and alternative hypothesis. Does the data suggest the number of students going on to a 4-year school has increased? So the null hypothesis would be that pi equals the status quo, what has been happening, 0.23. The alternative hypothesis is that pi is actually greater than 0.023. Notice p hat does not show up in there anywhere. When I did the mean hypothesis test for the mean and the median, notice the sample mean and the sample median did not show up in there anywhere. And again, it does not give a significance level, so we're going to work with 0.05. Now the test statistic is a z. Now we need to take a look at our assumptions. And the assumptions is that p hat is distributed normal. And this is reasonable if n times p hat is at least 5 and n times 1 minus p hat is also at least 5. Well, n times p hat is 44. If I just multiply this by n, I get, or by 137, I get 44. And n times 1 minus p hat, that's going to be 137 minus 44, which is 93. Check. Both of these are greater than 5. Now this z-test statistic, this is literally using a z-score. If I draw a picture, which is always a good idea, the picture would look like this: 0.23, and then up here somewhere is 44 out of 137. And I'm looking for this probability right here. And the actual test statistic will be z equals the observed value, 44 over 137, minus the mean under the null hypothesis, which is 0.23, divided by the standard deviation. Now the standard deviation is going to be based on the null hypothesis. So that's going to be the square root of 0.23, 1 minus 0.23, divided by n, which is 137. And then this will actually give me the value of z. And this z-score is the number of standard deviations above the mean. This is the actual test statistic. We could calculate this just like we would normally calculate, to simply find the probability of being greater than or equal to 44 over 137, given that pi is supposedly 0.23. So what we're really saying here in terms of the distribution is that not only is p hat distributed normal, but we're suggesting that p hat is distributed normal with a mean of 0.23 and a variance of 0.23, 1 minus 0.23 over 137. That's what we're suggesting is going on here. This is actually the sort of stuff that we've already done. Now, fortunately, we don't actually have to do all of this by hand. TC Stats will handle it for us. So if I jump to TC Stats, under one sample, you'll see Z for proportions. So select it. Then the null hypothesis is going to be equal to 0.23. And the confidence level, I'm not doing a confidence interval, so I'm not going to bother with it. P here, the sample proportion, was 44 over 137. If I had a decimal value, I could put in the decimal value right here and then add the sample size. But because I actually have the proportion, I don't need to. This is all I need. Now if I update, there's my value of Z, there's the p-value, and there's the sample proportion. So the p-value is 0.0056, and notice that the p-value is definitely less than alpha. Therefore, we will reject the null hypothesis and conclude that there is evidence or enough evidence to suggest the proportion has increased. Now, for my students, in addition to this, what you really need to add to this is everything that TC Stats give you. Give me Z. Give me the p-value, which I already did. And give me the sample proportion. Again, if you have the wrong answer, this will help me figure out what might have gone wrong to give you partial credit.